Today I want us to calculate, we'll start by drawing a free body diagram. We have these diagrams, so I want us to deal with the questions that we come across during an exam. So this one is the first question that you need to know. You need to know how to draw a free body diagram. Right, so how do we draw a free body diagram for this block? We have a normal force. We also have an applied force facing this direction. We also have weight pointing downwards. And we also have kinetic friction. Then we are done. This is your free body diagram. Then B, they say calculate the normal force for this diagram or for this block. So how do we calculate the normal force? You need to know that the normal force is equal to the weight, or I can say it in this way. The forces that are going upward is equal to the forces that are going downward. So here we have N is equal to W, equal to, the formula for W is mg. So the mass for this block is 5. Then this is constant, so it's gonna be 49 newtons. Then we are done. Then C, they say calculate the kinetic friction. So how do we calculate the kinetic friction for this block? The formula for a friction is Fk equal to mu k N. So mu k, we are given the mu k there. Mu k is 0,1. Then the normal force, we have our normal force here, which is 49 newtons. So 0,1 times 49, 0,1 times 49 is 4,9. 4,9 newtons. Right, then we have, then let us calculate. The next one is we're going to calculate the net force. Here. calculate the net force How do we calculate the net force? We write F net equal to all the forces that are acting horizontal, since the object is moving horizontal. So we're going to have FA, there are only two forces that are acting horizontal, so we have FA on the diagram plus FK is also acting horizontal. So the applied force, we are given the applied force on our diagram. It's 100. So let us choose the direction. You need to choose the direction. Take right as positive. So I like to choose the direction where the object is going. So this one is going to the right, so I'm going to take right as positive. Then our applied force is 100 plus, so our kinetic force is pointing to the left, so it's gonna be negative 4,9, So 100 minus 4,9, it's 95,1. Yes. So since it's positive, it's going to the right. Then the net force is 95,1 newtons to the right. Right. Then we are done with this one. Let us do the second one. First question: calculate a free body diagram. Draw a free body diagram. Draw a free body diagram for this block. So how do we draw a free body diagram here? We're going to have a normal force pointing upward. We're going to have a kinetic friction since it has a mu k. So a kinetic friction pointing to the left. As you know that kinetic friction opposes the motion of an object. So this object is going to the right. So our frictional force will point to the left. Then we're also going to have W, or weight, is okay. Right, so how do we draw? We know that this applied force is acting at an angle, so it will have components. So it will have fx and fy pointing upward. Fy. Right. So we are done. Then calculate the normal force. Calculate the normal force How do we calculate a normal force if we have an applied force that is acting at an angle? Right, okay. So we know that all the forces that are acting upward are equal to all the forces that are acting downward. So we're going to have something like this. It's N plus Fy equal to W. These are all the forces that are acting upward, equal to the forces that are acting downward. So we're going to make N the subject of the formula, W minus Fy. So let us calculate W. The formula for W is mg. The mass for this object is 9,8, which is 49 newtons. Then we also have Fy. We need to calculate Fy. So our Fy is gonna be F sine theta. So F is 150. If you check on the diagram, so the angle there is 30 degrees. So 150 times sine 30, it's 75 newtons. Right, okay. Now we substitute 49 something is wrong with my calculation here. We can't have a normal force that is negative, so I made a mistake with my values here. I need to fix something. Okay. I'll be back, guys. So I think I'm going to have another live post where I'll be fixing the values so that we're going to have an appropriate value for the normal force. Yeah, thank you.